Plug fuses are a type of electrical fuse designed to be plugged into a fuse holder. They are typically made of ceramic or glass and have a metal element that melts and breaks the circuit when the current exceeds the fuse's rating. Plug fuses come in various sizes and amperage ratings. Plug fuses are commonly used in residential, commercial, and industrial settings to protect electrical circuits from overcurrents. They are often used in older electrical installations and in applications where it's necessary to easily replace a blown fuse. The Edison base is a type of light bulb base that was invented by Thomas Edison. It has a screw-type thread and two contacts, one on the base and one on the side of the bulb. The base allows the bulb to be screwed into a light socket. Type S is a classification for Edison base light bulbs. It refers to the shape of the bulb, which is a straight-sided bulb with a pointed tip. Type S bulbs are commonly used in household lighting applications. Electrical circuits must be protected from overcurrents, which occur when the current flowing through a circuit exceeds its design capacity. This can happen due to various reasons, such as short circuits, overloads, or ground faults. Overcurrents can cause damage to equipment, wiring, and even start fires. Fuses and circuit breakers are two common types of overcurrent protection devices. Fuses are one-time use devices that melt and break the circuit when the current exceeds their rating. Circuit breakers, on the other hand, can be reset and reused after tripping. The choice between fuses and circuit breakers depends on the application and the desired level of protection. In residential settings, both fuses and circuit breakers are commonly used. Fuses are often found in older homes, while circuit breakers are more common in newer homes. Both devices provide adequate overcurrent protection when properly sized and installed. In commercial and industrial settings, circuit breakers are generally preferred due to their ability to be reset and reused. This reduces downtime and maintenance costs compared to replacing fuses. However, fuses may still be used in certain applications where their specific characteristics are advantageous. When selecting a fuse or circuit breaker, it's crucial to choose the correct amperage rating for the circuit it's protecting. The amperage rating should be slightly higher than the normal operating current of the circuit, but low enough to protect the wiring and equipment from damage in the event of an overcurrent. The National Electrical Code, or NEC, provides guidelines for selecting the appropriate overcurrent protection for various types of circuits. It's essential to consult the NEC and follow its recommendations to ensure electrical safety. The NEC specifies requirements for overcurrent protection in Article 240. This article covers various aspects of overcurrent protection, including the types of overcurrent protection devices, the ratings, and their installation requirements. Article 240.4 addresses the protection of conductors. It states that conductors must be protected against overcurrent in accordance with their ampacities. The ampacity of a conductor is its current carrying capacity, which depends on its size, insulation type, and installation conditions. Article 240.5 covers the protection of flexible cords and fixture wires. These types of conductors have lower ampacities than standard building wires and require special protection. Article 240.6 specifies the standard ampere ratings for fuses and circuit breakers. These standard ratings ensure that overcurrent protection devices are readily available and can be easily replaced. Article 240.15 covers the location of overcurrent protection devices. It states that overcurrent protection devices must be readily accessible and located where they will provide adequate protection for the circuit. Article 240.20 addresses the enclosure requirements for overcurrent protection devices. It states that overcurrent protection devices must be enclosed in a suitable enclosure that protects them from physical damage and environmental conditions. Article 240.21 covers the protection of tap conductors. Tap conductors are conductors that are tapped from a main feeder to supply power to a specific load. These conductors must be protected against overcurrent in accordance with their ampacities and the requirements of Article 240.21. Article 240.22 addresses the protection of fixture wires. Fixture wires are used to connect lighting fixtures to the branch circuit. These wires must be protected against overcurrent in accordance with their ampacities and the requirements of Article 240.22. Article 240.23 covers the protection of motor circuit conductors. Motor circuit conductors are used to supply power to motors. These conductors must be protected against overcurrent in accordance with their ampacities and the requirements of Article 430. Article 240.24 addresses the accessibility of overcurrent devices. Overcurrent devices must be readily accessible so that they can be easily inspected, tested, and replaced. Article 240.40 covers the disconnection and removal of overcurrent devices. Overcurrent devices must be able to be disconnected and removed from the circuit without exposing personnel to electrical hazards. Article 240.50 addresses the mounting of overcurrent devices. Overcurrent devices must be securely mounted in a suitable enclosure to prevent them from being dislodged or damaged. Article 240.60 covers the use of plug fuses. Plug fuses are a type of fuse that is designed to be plugged into a fuse holder. They are typically used in residential and light commercial applications. Article 240.61 specifies the ampere ratings for plug fuses. Plug fuses are available in ampere ratings ranging from 1 to 30 amps. Article 240.80 covers the use of cartridge fuses. Cartridge fuses are a type of fuse that is designed to be inserted into a fuse holder. They are typically used in commercial and industrial applications. Article 240.81 specifies the ampere ratings for cartridge fuses. Cartridge fuses are available in ampere ratings ranging from 1 to 6,000 amps. Article 240.83 covers the marking requirements for fuses. Fuses must be clearly marked with their ampere rating, voltage rating, and interrupting rating. The ampere rating indicates the amount of current that the fuse can carry before it melts and breaks the circuit. The voltage rating indicates the maximum voltage that the fuse can safely interrupt. The interrupting rating indicates the maximum amount of fault current that the fuse can safely interrupt. It's important to select a fuse with an interrupting rating that is equal to or greater than the available fault current at the point of installation. Failure to do so can result in the fuse failing to clear the fault and potentially causing a fire or explosion. Edison base fuses are a type of plug fuse that have a screw and base similar to that of a standard light bulb. They were commonly used in older electrical installations, but they are now largely obsolete due to safety concerns. Edison base fuses are easily interchangeable, meaning that it's possible to replace a fuse with a higher amperage rating than the circuit is designed for. This can lead to overcurrents and potentially cause damage to the wiring and equipment. Type S fuses were developed to address the safety concerns associated with Edison base fuses. Type S fuses have a non-interchangeable design, meaning that only fuses with the correct amperage rating can be installed in the fuse holder. This prevents overfusing and reduces the risk of overcurrents. Type S fuses also have a tamper-resistant design that makes it difficult to bypass or disable the fuse. When replacing fuses, it's crucial to use the correct type and amperage rating. Using the wrong type of fuse can compromise the safety of the electrical system and potentially lead to dangerous situations. Always consult the NEC and follow its recommendations for overcurrent protection. In addition to fuses, circuit breakers are another common type of overcurrent protection device. Circuit breakers are electromechanical devices that automatically interrupt the circuit when an overcurrent is detected. Unlike fuses, circuit breakers can be reset and reused after tripping. Circuit breakers are available in various types, including thermal magnetic only, and electronic trip circuit breakers. Thermal magnetic circuit breakers are the most common type and use a combination of thermal and magnetic elements to detect overcurrents. Magnetic-only circuit breakers are used in applications where fast tripping is required, such as in motor circuits. Electronic trip circuit breakers use electronic sensors to detect overcurrents and provide more precise and adjustable protection. When selecting a circuit breaker, it's important to consider the following factors. Firstly, the voltage rating. The voltage rating of the circuit breaker must be equal to or greater than the voltage of the circuit it's protecting. Secondly, the ampere rating. The ampere rating of the circuit breaker must be slightly higher than the normal operating current of the circuit, but low enough to protect the wiring and equipment from damage in the event of an overcurrent. Thirdly, the interrupting rating. The interrupting rating of the circuit breaker must be equal to or greater than the available fault current at the point of installation. Fourthly, the type of circuit breaker. The type of circuit breaker should be selected based on the specific application and the desired level of protection. Fifthly, the number of poles. The number of poles of the circuit breaker should match the number of conductors in the circuit it's protecting. In residential settings, single-pole circuit breakers are typically used for 120-volt circuits, while two-pole circuit breakers are used for 240-volt circuits. In commercial and industrial settings, three-pole circuit breakers are commonly used for three-phase circuits. Circuit breakers must be installed in a suitable enclosure that protects them from physical damage and environmental conditions. The enclosure must be properly grounded to prevent electrical shock hazards. Circuit breakers should be periodically inspected and tested to ensure that they are functioning properly. Testing can be performed using a circuit breaker tester, which simulates an overcurrent condition and verifies that the circuit breaker trips as designed. If a circuit breaker fails to trip when tested, it should be replaced immediately. Overcurrent protection is an essential aspect of electrical safety. By properly selecting and installing overcurrent protection devices such as fuses and circuit breakers, it's possible to protect electrical circuits from damage and prevent electrical fires. Always consult the NEC and follow its recommendations for overcurrent protection. Additionally, it's important to be aware of the hazards associated with electrical work and take appropriate safety precautions. Always de-energize the circuit before working on it, and use appropriate personal protective equipment, such as gloves and eye protection. If unsure about any aspect of electrical work, consult a qualified electrician. Edison base light bulbs are a type of light bulb that has a screw and base similar to that of a standard light bulb. The Edison base was invented by Thomas Edison and is still widely used today. Edison base light bulbs are available in various sizes and wattages, and they are commonly used in residential, commercial, and industrial lighting applications. Type S light bulbs are a type of Edison base light bulb that has a specific shape. Type S light bulbs are characterized by their straight size and pointed tip. They are often used in decorative lighting applications such as chandeliers and sconces. Type S light bulbs are available in various wattages and finishes, and they can be used with both incandescent and LED light sources. When selecting light bulbs, it's important to consider the following factors. Firstly, the wattage. The wattage of the light bulb should be appropriate for the fixture it's being used in. Secondly, the light output. The light output of the light bulb is measured in lumens. Choose a light bulb with a light output that is appropriate for the application. Thirdly, the color temperature. The color temperature of the light bulb is measured in Kelvin. Choose a light bulb with a color temperature that is appropriate for the application. For example, warm white light bulbs around 2700 Kelvin are often used in living rooms and bedrooms, while cool white light bulbs around 4000 Kelvin are often used in kitchens and offices. Fourthly, the energy efficiency. Choose a light bulb that is energy efficient to save money on your electricity bill. LED light bulbs are much more energy efficient than incandescent light bulbs. Fifthly, the lifespan. Choose a light bulb with a long lifespan to reduce the frequency of replacement. LED light bulbs have a much longer lifespan than incandescent light bulbs. When replacing light bulbs, be sure to turn off the power to the fixture before removing the old bulb. This will prevent electrical shock hazards. Also, dispose of used light bulbs properly. Incandescent light bulbs can be disposed of in the trash, but compact fluorescent light bulbs, or CFLs, contain mercury and should be recycled. Electrical safety is paramount when working with electrical circuits and equipment. Always follow safe work practices and consult with a qualified electrician if you have any questions or concerns. Understanding basic electrical concepts such as overcurrent protection, fuses, circuit breakers, Edison base light bulbs, and Type S light bulbs can help to ensure electrical safety and prevent electrical hazards.